Hello everyone. In this video, I'm going to go over part 1F of the test 1 practice questions, which is about the accumulator pattern with conditionals. So this is the most complicated part of the reading code part of the test. So you have to be pretty careful. So let's go over the first one. It looks like we're doing t starting off as empty string. That is probably going to be our accumulator variable that we're going to be adding things to. So t is starting off as an empty string. And then we're going through each character in the word Susquehanna, and X is going to loop through each character in Susquehanna. So the first time this loop runs, X will be the capital S right here. And then what are we doing each time this loop runs? We are checking if that current character is in the string lowercase a, e, I, o, u. So if the character X is in a, e, I, o, u, then we are redefining t to be the current value of t plus an asterisk. So basically we add an asterisk onto the end of t. Otherwise, if the current letter in Susquehanna is not one of these lowercase vowels, then we're adding that letter onto the end of t. So you see basically what's happening here is we're adding either an asterisk to t or we're adding the current letter in Susquehanna to t. So if the current letter in Susquehanna is a vowel, then we add an asterisk to t. Otherwise, if the current letter in Susquehanna is not a vowel, then we add that letter to t. So what's going to happen here is we're going to end up basically bleeping out all the vowels in Susquehanna and replacing them with asterisks. But let's go over a few runs of the loop in detail so you guys can see kind of how it happens. So the first time this loop runs, X is going to be the uppercase S. Okay, and then we're checking, is that uppercase S in this vowel string here? No, it is not. So we're going to do this else code down here. So t is going to be defined or assigned. T is going to be assigned the value of current value of t, which is empty string, plus current value of X, which is this capital S character. Okay, so empty string plus anything just leaves you the other thing. So you're not adding anything onto that S. So t is going to be that capital S for the first value that prints out over here. So this print is happening outside of the if-else blocks, but it is inside of the loop. So after you do the if or the else, you do the print, and then you go up to the top of the loop and repeat with the next value of X. So let me erase for the next part. So next value of X is going to be the lowercase u. Okay, and we check if X, the lowercase u, is in a, e, I, o, u, and it is in there. So that is true. So now we're going to do this line of code. T is assigned to be current value of t, which is the capital S. We just printed it out, plus asterisk. Okay, and so that's just going to glue those two together. We're going to get S asterisk. Okay, and then we're going to print that out. And then we come back to the top of the loop. Next value of X is going to be the lowercase s. So this third character right here. We check if that is in A, E, I, O, U, and it's not. So we're going to skip down here and we're going to do the else block. So t is assigned to be current value of t, which is S star, plus current value of X, which is lowercase s. Okay, and so that's just going to be capital S star lowercase s. So hopefully you guys see the pattern of like what's happening here, and you don't have to actually keep like writing it out little by little. You can just kind of continue the pattern for the rest of the loop. So for the next time it runs, X is going to be the Q. Okay, and Q is not in the vowel string, so we are going to add that Q to the end of T. The next time the loop runs, X is going to be the lowercase u. U is in the vowel string A, E, I, O, U, so we're going to add a star to the end of T. Okay, and the next value for X is going to be that lowercase e, which again is in the vowel string, so we're going to add a star instead of adding the e. And then it just keeps going on like that. Like every time you have a vowel, just put a star. Every time you don't have a vowel, just put that letter. Okay, so it's like pretty straightforward, hopefully. So it's going to be an N, then another N, and then lastly, we're going to star out the A, like that. Okay, so we can go ahead and run this and make sure, yep, that's exactly what happens. Okay, let's do the next one. So we actually have two accumulator variables here. One is called P, one is called N. They both start off at 0, so we're probably going to be adding things to them. And what happens is we're going to go through this list of numbers here. So x is going to become each number in this list one by one. So first x will be -2. And then we're checking if x is greater than 0. And if x is greater than 0, then we are adding x to the current value of p, and that's going to be the new value of p. So we increase p by x, and then we print out that new value of p. Otherwise, if x is less than 0, we are adding x to n, and that is what we're going to print out. So basically we have two totals here, a positive one and a negative one. So the p is for positive numbers, the n is for negative numbers. And what about 0 itself? If x is 0, nothing happens. So both of these blocks will get skipped over because 0 is not greater than 0 and it's also not less than 0. Okay, so let's go over a couple first values in detail and then we can kind of like do the rest more quickly. So the first time this runs, x is going to be -2. We check, is x -2, is that greater than 0? No. So we come down here, we check, is -2 less than 0? Yes. So we're going to do this one. So n is assigned to be current value of n, which is 0, plus current value of x, which is -2. So we get -2, and then that is what is being printed out. So sometimes we print p, sometimes we print n. We print whichever one just got updated. Okay, but it doesn't, when we print it out, we're not like specifying which one is which. So that could be a little bit confusing, I guess. Okay. Okay, so for the next time we run the loop, x is going to be 3. So we check, is 3 greater than 0? Yes, it is. So we're going to do p. We're going to assign p to be current value of p, which is still 0, because we haven't done anything to p yet, plus current value of x, which is 3. So p is going to be updated to be 3, and then we're printing out that value of 3. Okay, and then it basically just keeps going like that. Just add the negative ones to n, add the positive ones to p, print out whatever the new value is. Okay, so let's go through these one by one. So the next x value is 4. We're going to add that to p, which is currently 3. So that's going to be 7. Okay, the next x value is -1. So we're going to add that to n. The last value of n, the current value of n, is this -2 that we had printed out before. So that's going to be -3. Next we do 0. That doesn't get added to either one. All of this gets skipped over. Nothing gets printed out. So we go on to 15. That's going to be added to p, the positive total, which is currently 7. So that's going to update to 22. And then lastly, we're taking this -3. We're adding that to current value of n, which is currently -3. So we're going to get -6. Okay. And then you can run this and just check. See, you get the same as what I put down here. All right, so, oops, I left some comments on this one. I'll take them off. Or actually, maybe I can just go over what they say since we needed to know this stuff anyway. So the range 8 part here, it's a little bit mysterious because we're starting off with A being 6. This one is not exactly accumulator pattern, but it's kind of similar enough that I thought it was the right place to put this problem. So we have for I in range 8. And the interesting thing about this is I is actually not being used down here at all. So having I go through range 8 is basically just a way to make this code run 8 times. But we didn't really need the value of I for anything. But anyway, so range 8 is going to be the values from 0 to 7. So always start at 0 when there's just one number in the range, and then stop one before that number. And then what this code is doing is it's checking, is the value of A even? Okay, so it's calculating the remainder of dividing A by 2. And if that's 0, then we're going to do this code. So that's basically just checking if A is even. Because for even numbers, when you divide by 2, you get a 0 remainder. And then otherwise, when A is not even, we do this code here. So what's going to happen is A is either going to get cut in half, and that'll be the new value of A, or A gets tripled and then 1 gets added to it. So you're doing one of those two things, either cut A in half or triple it and add 1. Okay, and then once you've done that, you print out the new value of A. So for the first time we run this code, I is going to be 0 and A is 6. So we're going to check if 6% 2, remainder after dividing 6 by 2 is 0. Yes, it is. So we're going to divide A in half, and that will be the new value of A. So A is going to be 3. So when you do this double slash here, double slash 2, if you do that to an even number, it will be exactly half the number. Otherwise, if you do it to an odd number, it's like the number of times that 2 goes into that number, so it's it's like a little bit less than what half would actually be, because you never get a decimal from this, you get an integer answer. Okay, so anyway, that'll be the new value of a. So that's going to print out when we get to the print command down here. So the next time we run the loop, the value of I is 1. And now 3 is our new value for a. 3 is not even, so we're going to do this else block right here. So we're going to do 3 times 3 plus 1. That's going to be 16. Okay. Now 16, oh, why is that doing that? Oh, right, I have to indent these. Okay. So now 16 is even. So the next time we run the loop, I is going to be 2 and a is going to be 16, which is even. So we're going to cut that in half again. So the new value of a is going to be 8. Okay. Wait a minute. Did I do something wrong here? Hold on. Oh yeah, I did. It wasn't 16, is it? It's 3 times... Yeah, when I did 3 times 3 plus 1, that should be 10, not 16. Sorry about that. I'm getting tired. Okay, so that one is 10. And then when we come through the next time, when a is 10, okay, so when I is 2 and a is 10, check if a is even. 10 is even, yes. So we cut it in half and we get 5 for a. Okay, and then we come through again when I is 3 and a is 5, and we're doing this one because a is not even. So it'll be 5 times 3 plus 1. That will be 16. Okay, and then the next time we come through, we're going to be cutting a in half. So like once you kind of figure out the formula, you can just go like pretty quickly through these. And then just make sure you get 8 printouts, because this should run 8 times, and this is 8 of them, I think. So this sequence that we did here is, this is related to a problem called the Collatz conjecture. Mathematicians have conjectured that no matter what number you start with for a, if you keep going through this code for long enough, you know, maybe more than 8 times, like 80 times or 8,000 times or 8 million times, but eventually you'll always get 1. So that is the conjecture, but no one has yet proven it. So if you want to impress a bunch of mathematicians, you can try to prove that. It has been said that the Collatz conjecture has wasted the most time of all mathematicians in the world, of all problems that we've ever gotten interested in. I myself have wasted many hours working on the Collatz conjecture. All right, so that's it for this video, and I will resume in the next video with the writing code part of the practice questions.